we're digging into a few really distinct areas. Think of it as our mid-October 2025 tour of what's new and honestly kind of mind-blowing in tech and AI. So how about this? 1,600 kilometers. That's nearly 1,000 miles on a single electric car charge. Or maybe an AI that's, get this, 50 times more energy efficient than the big models we use now.
Welcome back to the Deep Dive. We've got a stack of sources today covering everything from revolutionary hardware, completely new ways of building AI, and even how people are actually buying things differently now. It's a real snapshot of the cutting edge for mid-October 2025.
Yeah, the source material is fascinating. It spans, deep chemical engineering right through to high-level digital strategy. But there's a thread, a common drive we picked up on. It's this relentless push for, well, extreme efficiency. And alongside that, this constant battle for platform dominance, becoming the way things are done, we're looking for how they're actually achieving these breakthroughs.
Okay, let's start with the hardware then. That efficiency angle really hits home with batteries, especially when you talk about eliminating stuff. 24M Technologies, that headline, 1,600 kilometers range. I mean, that sounds impossible. What's the magic?
It's less magic and more radical redesign. They call it electrode to pack, or ETOP. See, the problem with current batteries, standard lithium-ion ones, they're full of parts that don't actually store energy. Individual cells wrapped in casings, separators, packed into modules. All this adds weight and volume, but no power. ETOP basically says, let's get rid of all that.
So they're literally taking the core bits, the anodes and cathodes, and stacking them directly into the final battery pack. No individual cell cans, no modules.
Exactly. Cutting out all that inactive material. That's how they're claiming that 50% jump in energy density without making the battery physically bigger.
Wow. Okay. But it's not just about density, is it? The manufacturing sounds different too.
Oh, absolutely. It's an integrated manufacturing approach. Think about it. If you remove all those individual cell packages, you have to solve problems like heat management and safety differently. They seem to have cracked that with large, stacked electrode pairs.
And that simplifies the assembly line.
Massively. The sources say a single piece of equipment can handle the sealing, stacking, wiring, closing the whole pack. That's huge for cutting costs and, speeding up production.
Right. And 24M CEO Naoki Oda, he specifically mentioned this is vital for the U.S. to compete with Asia, right? What's the disadvantage he's pointing at?
It's mostly about scale and the speed of adopting new manufacturing tech. Asian producers, especially in China and South Korea, have really optimized making traditional cells super efficiently.
So they have that locked down.
Pretty much. Oda's point is that to compete, you can't just tweak the old way. You need a leapfrog innovation, something that changes the battery structure itself, like ETOP.
And this isn't happening in a vacuum. We see other efforts mentioned, right? Like MIT's model for lithium-ion, Kiel University, looking at lithium-sulfur for super fast charging.
Exactly. Under 30 minutes, potentially. It's a global race. And even consumer electronics companies are jumping in. Look at Xiaomi talking about 1,200-kilometer range, plus adding 800 kilometers in just 10 minutes of charge with their design.
So the big takeaway on batteries is eliminate everything that isn't pure energy storage or enabling efficiency. Ruthless optimization.
That's the theme.
Okay, let's carry that theme, ruthless elimination of inefficiency, over to AI. We're shifting from chemistry to algorithms. China's spiking brain 1.0, they call it a brain type model. Why is that structure such a big deal compared to, say, the LLMs we hear about constantly?
Well, the fascinating or maybe alarming thing about the current main architecture, the transformer model used in most LLMs, it's incredibly energy hungry.
How so?
In a transformer, basically every artificial neuron is on all the time, processing, calculating, even if the data it's seeing is redundant or just zero. It's constantly burning energy, a continuous, exhaustive process.
Right, always running at full tilt, even if the task doesn't need it.
Precisely. Spiking brain is different. It uses what's called spiking computation. It tries to mimic biological neurons more closely.
Okay.
Which means it's event-driven. A virtual neuron only fires or activates when it gets a specific, significant input signal. Otherwise, it stays quiet.
Ah, so it's not always on. It only works when needed.
Exactly. Sparse activation. Intermittent. That's why the sources are reporting these massive energy savings, up to 50 times less energy compared to those constantly computing models.
And the performance isn't sacrificed, because the numbers mentioned are, well, they're staggering. A 7 billion parameter version being 100 times faster on a huge query. 4 million tokens.
Yeah, the speed comes with efficiency. And get this, it achieved its results using only 150 billion training tokens.
Only 150 billion? What's typical?
For models aiming for that level of performance, it could be trillions. So 150 billion is like less than 2% of the usual training data volume. Think about the cost savings just in training these things. It massively lowers the barrier to entry.
That feels strategic, like aiming for independence.
Oh, definitely. It's explicitly designed to run stably on MEDIX chips. Those are made in China. Reports say it ran for weeks without issues on this local hardware.
So reducing reliance on, say, NVIDIA?
That seems to be a major goal. And the application focus is interesting too. It's geared towards tasks needing deep analysis of massive amounts of context. Think complex legal documents, analyzing genetic sequences, huge scientific data sets. Depth over breadth, maybe?
Okay, so platform independence on the chip level. Let's look at platform dominance on the software level. OpenAI's big move with ChatGPT, their Dev Day 2025 announcement, wasn't just an update. It sounded like they want ChatGPT to become an operating system.
That's exactly the ambition. It's a huge strategic shift. They're rolling out a new software development kit, an SDK. And what this does, fundamentally, is allow developers to build and plug their own applications directly into ChatGPT.
So apps living inside the chat.
Kind of. Sam Altman's vision is for a new generation of adaptive, personalized applications. But the key difference is how you interact, not by clicking buttons or menus, but purely through discussion, through language.
Which brings us to this idea of AI agents. They're not just apps, are they?
No, that's the crucial distinction. An AI agent isn't like a traditional app you open and control directly. It's more like a semi-autonomous program. You give it a complex goal.
Right.
Like, plan my weekend trip to Lisbon, find flights and hotels that fit my budget and dietary needs, check the weather, and let my partner know the plan. The agent is supposed to understand that intent, figure out the steps, and then proactively use other tools, flight apps, hotel sites, calendars, messaging, to get it done with minimal hand-holding from you.
Okay, that's a big leap. And they release tools for this. Agent Kit.
Right, Agent Kit. It includes things like an agent builder, apparently for people who don't code, something called Chat Kit to add conversational abilities to existing software, and a connector registry for accessing APIs securely.
So the strategy is make ChatGPT the place where language is the only interface you need, the central hub.
Exactly. Position ChatGPT is the ultimate agentic platform. If you want software to do something, you tell the agent in natural language. Language becomes the command line for everything. It's a bold play for ecosystem control.
Let's bring this high-level AI stuff down to earth. How is all this changing things for regular consumers? The Consumer Report 2025 looked at buying behavior in Europe and the US. What's shifting?
The report highlights a really significant generational divide, particularly around trust and how people find products. Gen Z, the 18 to 25 group, is way ahead on using AI for shopping.
How so?
It's this shift to search idea. Get this, 62% of Gen Z are using generative AI tools, like chatbots, to help them decide what to buy. Compare that to only 37% of people over 46.
Wow, that's a big gap. Why are younger people trusting AI more for shopping advice?
It seems they see it as a super efficient way to cut through all the noise, a personalized filter against the flood of marketing online. They grew up with this tech.
And this forces brands to adapt. GEO, generative engine optimization.
Exactly. Brands are realizing they need authentic, genuinely helpful content because that's what the AI is likely to find and recommend. It pushes them away from just flashy ads towards substance.
Authenticity that connects to reviews, right? They're still king.
Absolutely critical. Across all ages, reviews are the bedrock of trust. And what's really interesting is the impact when reviews are missing.
People get suspicious.
Hugely. 54% of people in the survey said they'd just look elsewhere if there are no reviews.
Yeah.
53% said they lose confidence in the product entirely. And Gen Z specifically wants visual proof. 51% check out videos from creators on Instagram or TikTok before buying. They want to see it used by a real person.
So that ties into social commerce too. Even if platforms like TikTok Shop aren't huge everywhere yet.
Precisely. The success globally hinges on user-generated content UGC. Real people, real experiences. 59% of respondents globally click more on ads featuring actual users, not celebrities or slick campaigns. Peer recommendations are beating polished marketing.
Which leads naturally to brand communities. Sounds like another area where younger consumers are way more involved.
Oh, massively. 70% of Gen Z and millennials are willing to join a brand's community, compared to just 22% of the over 46 group. And when brands get this right, The results are impressive.
Examples.
The sources mentioned Carrefour, the retailer. They apparently tripled the average spending for their community members compared to regular shoppers. And Sephora doubled its conversion rate just by integrating customer reviews and UGC videos onto their product pages. It builds loyalty and trust.
Okay, so let's try and tie all these threads together. We've gone from batteries to AI brains to ChatGPT becoming an OS to how Gen Z shops. What's the common denominator here?
It really does circle back to that initial idea. Breaking down old, inefficient, always-on structures. Think about it. Getting rid of inactive battery materials, replacing the energy-guzzling transformer AI with event-driven spiking models, swapping button clicks for conversational agents.
It's all about removing the unnecessary overhead.
Exactly. It's a drive towards extreme efficiency, towards selective activation, only using resources when genuinely needed. And the outcome seems to be more power, more personalization, more direct interaction.
So here's a final thought to leave you with. If the cutting edge in everything from batteries to AI platforms is moving towards the selective event-driven approach, activating only when necessary, like spiking neurons or cell-less designs where you're still running on always on, what parts of your own work or how you use technology are stuck in that old constant activation mode? What could you maybe eliminate or make sparse for a massive gain in your own efficiency or focus? Something to ponder. This has been another deep dive. Thanks for tuning into Le Podcast de Philippe. And hey, if you found this useful, please do hit that subscribe button. We're trying to get to 1,000 subscribers. And honestly, we're almost there. Your click really helps. Thanks again.